Here we go. So, let's do a quick recap because I'm more interested in just showing you if last session's theory was too confusing, then today's session I'm wanting to just give you a formula that you can then just apply, which is what most Year 12s are able to do to find the derivative or essentially the gradient of a particular point, which is called instantaneous rate. So here's a quick recap. Average rate of change, remember that is the gradient between, how many points again? 2. So it's between 2 points, whereas instantaneous rate of change, which is really what calculus is all about, that was the gradient at a single point on the curve. So the difference between them is one requires 2 points, one only requires 1. Okay? We don't need to do example 1 here. You can do it yourself if you want. It's just getting used to using function notation, but it's the same thing. Find the gradient. We do have visitors. No, maybe that. Oh, yes. Sunny. Oh, Raf. Yep, that one. Thank you. All right, so first example, I'm just going to skip that one because that we did our last session. It's just getting used to y2 minus y1 over x2 minus x1, which is the definition of a gradient, which is what you would have done back in year 9 for average rate. The example sheet that I gave to you was this one. You had a whole page to do. If you didn't have a go with it, this is now my second time explaining. Hopefully after the first time you had a bit of think. This time I'm going to do it again, but I'm going to just focus on y2 minus y1, x2 minus x1, rather than linking function notation, because one of the challenges at the moment is your ability to read that notation. So that's the scary part. So instead, I'm going to explain it using y2 minus y1, x2 minus x1, and that will make a bit more sense to you. Okay? So here we go. Same idea. So here we've got a function. It is a quadratic function where it's x squared plus 3x. And I've already typed it up on Desmos so you can visualize what it looks like. So this is what it looks like. Whoops, not that one. This one. This is what the graph looks like. Okay, it has an x-intercept at -3, 0. So I'll label it. And it has an x-intercept at the origin, so 0, 0. That's what the equation looks like. What we're asking right now is we're saying, for that graph that you can see, find the instantaneous rate of change, which means the gradient at x equals 1. So at x equals 1 right now, so where's 1? 1's over here. So if you have a look on the graph, when x equals 1, there is a coordinate on the graph at 1, 4. Right? So let's write that down. So our coordinates, I've got the coordinates when x is equal to 1. I know the answer's 4 there, just looking at the graph, but if I didn't have the graph, how would I have gotten 4? Where'd the 4 come from? Yeah, because remember, that's your equation. That's saying y is equal to x squared plus 3x. So if you know x is 1, well then the result would be y is equal to 1 squared plus 3 times 1. So it makes sense why it's 4. Right? So far so good. Now, we've got 1 point. We only need 1 more point. Okay, we only need 1 more point to find the gradient of a line. So here, I'm going to call this x1, y1. So we're half the formula there already. We're almost there. We just need 1 more point. Now this is where the theory comes in. I'm going to try to bring you into the picture. So we need 1 more point. Okay, we need an x coordinate and therefore we can find the y coordinate, right? So here's the theory. Here's 1, 4. 1, 4 is over here. There's the point. Now, I don't have a second point because remember, I'm trying to find the gradient of a line, where my pen is, that is touching exactly only 1 point. The problem is we don't have a technique at the moment. So what we do is we pick another point. We pick a second point anywhere. We could pick at 2 and pick a second point on the graph and then connect the 2 dots using a gradient, right? The problem with that is the gradient won't be exactly the same as the gradient at exactly at 1, 4. What I showed you in the last session was that to get my second point, the best way to get close to this gradient right at 1, 4 was that if my second point was really close to the original point. Okay, let me say that again. So I'm going to print screen this one. I'm going to print screen this so you can visualize what I'm saying, so I can draw on the graph. This is what I'm saying. We've got the graph over here. So we need a second point. Remember, the whole point is to figure out a second point. This is my point right there at x equals 1. If I chose another point further out, so the second one over here, see if I connect those two lines, those two dots, sorry, those two dots, that tangent is not the same tangent as the one that touches the purple line, or the purple dot. Then, does it touch the purple? Kind of. Not really. It's not a really good tangent line. But the point is, can you see how the green line and the purple line, they're not aligned? But how do we make it aligned? We realize that the closer I pick my second point, rather than picking this one here, instead of picking that being my second point, my second x coordinate. So my first one was at x equals 1. The closer the second point is for the x coordinate to the first one, the closer is the gradient is. Does that make sense? Okay, because that's the theory. That is literally the definition of first principles. So the question is, what's the number can we choose? So in the example I did in our session was I said, well, let's do 1 unit away. I chose 2. Then I said, can we do better? Someone said 2.5. So we did, all right, 2.5 is better. Then Una said 2.1. And then Olivia said 0.001. But what we saw was the distance between the original point to the next point, the smaller that distance, the better our estimate of the gradient should be at a single point. So this is what we did. We said, well, I chose 1 distance away from 1. So it's 1 plus 1. Or you said, maybe do halfway. So 0.5. Then Una said plus 0.1. Then Olivia said plus 0.0001. Okay, so instead of 1, my second point will be 1.0001. Right? So we said, well, this is very arbitrary, isn't it? This number that you guys are choosing. So what we say is, why don't you just give it a letter and just say this is the smallest distance that you can come up with. So we gave it a letter and we said, let's call it h. So we think about the number line again. So you had at x equals 1, that's your first point. We just need a second point now. So what I'm saying is, well, why don't you pick a second point and write it arbitrarily? This is starting at 1. Why don't I just say this is 1 plus h? So it's just h distance away. The distance between this one and that one is h distance away. What is h? H is that small number. Could be 1 unit away, could be half a unit away, could be 0.1 unit away, or could be 0.0001 away. The point is h represents where your starting point is. That's your first coordinate, which you all agreed. My second x coordinate that I'm choosing is going to be very, very close to 1. Just that h is a very, very, very small number. That's the theory. So far, so good? Okay, so I'm going to go back to our notes again. And what I'm trying to say to you, and this is the key part to be able to do first principles. So if you didn't get it the first time, hopefully this now makes more sense. So our first point was 1. And all I'm doing now is I'm saying, well, let's do 1 again, but plus a little small number just slightly across. And we're saying 1 plus h. So that's my x2. That's my second x coordinate. Now I'm going to ask you the same question again. See, when you had x is equal to 1, I asked you, how did you find 4? You told me sub it into the equation to find the y coordinate. Well, what if x is now 1 plus h? How do you find the y value? What do you have to do? Yeah, you sub this into the equation. This is your x coordinate. So what happens now is it becomes 1 plus h squared, because that's, I'm squaring the x, and the x is 1 plus h, plus 3 times x, which is 1 plus h. That's the only part that actually troubles students a lot. That concept of being able to find the y coordinate. All we did was exactly what you just told me. You said, take x, sub it in, and then evaluate. So I did the same thing. I just said 1 plus h, sub it in, evaluate. Now you can do that on a CAS. You can actually type in and type expand that, or we can do it manually right now. So here we go. Let's expand. 1 plus h squared. What does that give you?
1 plus 2h plus h squared.
Good. So that's quadratic expansion. Again, you can do it the long way, doing the distributive law. Doesn't matter which way. You can use a CAS. The next one, 3 times 1, 3 times h, is plus 3 3h. Simplify for me. What can we simplify?
4 plus 4h.
Good. So the 1 and 3 makes it 4. So we got 4 plus, and we notice that 2h plus 3h is 5h plus, you got h squared. So far, so good? Okay, so what are my two coordinates? Let's summarize again. Here's my first one, 1, 4. And my second coordinate I chose was 1 plus h. And the result was h squared plus 5h plus 4. So far, so good. So this is my x1, y1, x2, y2. This is the only bit that's considered first principles. This is the only part that's year 11. The stuff that I'm trying to say now is pretty much year 9 from here. So year 9 mathematics here, if I asked you to find the gradient, you would have said gradient is equal to y2 minus y1 over x2 minus x1. Here's my y2, which is why in the formula was called f of x plus h. That's what it is. That's what this represents. That's your y2. Okay, so you figured out this is now h squared plus 5h plus 4. Takeaway. So y2 minus y1. What's y1 again? 4. So they say take away 4 divided by x2. See, x2 right now is 1 plus h. Take away x1, which is 1. Can you see why in the formula? Notice here the 4's cancel out in the numerator. And denominator, 1 take away 1 cancels out, which is why in the formula, notice it's always h. So in the first principles formula, why is it always h on the bottom? It's because the original starting point, the very first coordinate you chose, when we said start at 1, those are always going to cancel out. That's why there's a h on the bottom there. Okay, so that right there is actually this formula right here. So let's simplify. We now have h squared plus 5h in the numerator divided by h in the denominator. You can see that numerator has a common factor of h, so factorize, take out h as a common factor. In the numerator, divided by h, and you can see h divided by h cancels out. And so therefore your gradient, what is your gradient actually equal to? It's h plus 5. But what was h again?
Very, very small.
It's a very, very small number. Now in the theory, this is what the theory is. First principle saying, okay, we want to know the gradient at one point. When you use h as a second point, but it's infinitely small, what we realize is actually the smaller this one gets, the gradient approaches a certain number. And clearly we can see there's a pattern. The gradient approaches, if this keeps getting smaller and smaller and smaller infinitely, we are actually approaching a gradient of 5. And that's how we then know the gradient of one single point. So if I go back to the graph again, back to the graph, I'm saying that the gradient, tangent line that touches that point, that has to approach. If h can get infinitely small, and we chose a second point that was really close and we found the gradient of it, it's actually really close to 5. That's what we can approximate it to, yeah, in the infinite world. So that's how we then are able to find the gradient of a straight line that touches only one point. So far, so good. That's first principles. That's a long way of doing it. And for every new function you get, there's a whole bunch of this substitution. This is the only pain of first principles. So if I gave you a sine function, you'll be going through all of this using sine. If I gave you a cubic function, you'll be doing all of that cubic. It's a pain to do. So what I'm teaching you today, if you didn't understand the theory, I'm teaching you now a shortcut to getting the answer of 5. And it only takes about 5 seconds once you learn the technique. It takes 5 seconds to figure it out. Okay? But that was the theory from last session. So today's session, if you flip over the next page, That's what we're going to work on. Now I'm just going to pause the video for a second. Let's go. All right, is it recording? Let me just double check. Yeah, all right, it's recording. So, summary. The skill I taught you just now, that's called first principles. And this idea that if h gets really small, that's what this means. So lim, h approach 0, that just means if it gets infinitely small, what does the gradient, this represents gradient, tend towards? And we can see it tends to 5. So I'm going to show you now a technique called a power rule. And with this technique, you can actually do what I just showed you much quicker. What? Oh, Emma. I love the face paint. That's so cool. All right. If you have a function that is what we call that has a power. So for example, x to the power of 1, you can use this rule. X to the power of 2, you can use this rule. If you have a function that is x to the power of negative 2, you can use this rule. If it was y equals x to the power of negative a third, you can still use this rule. How does this rule work? You've got an x to the power of n, so it has to have a power. It has to be by itself, so x to the power of something. Then with this rule, you can actually quickly find the gradient, which we call derivative or differentiate. Those are the two words, like that's the verb of doing it. You can differentiate it, and we call this f dash of x really the gradient. That's what it means. That's to find the gradient. So f dash, so f is a function. F dash means find the gradient. A is the coefficient. So it doesn't matter what the function is. The number that's multiplied to it will stay the same. Here's the rule. The rule states that it can just be whatever the power is, you bring it to the front, and you multiply to the coefficient, so that's n times a, and you minus the power by 1. Okay, so let's recap on what they're saying again. If I had, for example, y equals x squared, then the derivative, which I shouldn't do this, but this is bad notation. Don't copy that notation. It's just trying to separate it so you can see. Y dash, which is not how you're meant to write it. Y dash is equal to, now what's the power? What's the power for this function? It's squared, so it's a 2. So according to the rule says bring n. N's going to come to the front, so it's 2 times. What's the coefficient in front of the function right now? Which is a. What's the number that's multiplied to the function? 1. So there's no number in front of it, so usually it's 1. So 2 times 1 times function is x to the power of 2, but the rule says minus the power by 1. So what's the derivative, or what is the gradient function? The gradient function is 2 times 1, which is 2. X to the power of 1. What this tells you is you can find the gradient for x squared at any point, as long as you know which x value you want. So if you know if x equals 1, sub 1 in, and it tells you what the gradient is. If you know at x equals 2, sub 2 in, and it will tell you what the gradient is. Let's do a practice of our example. So let's go back to our example again. What's our function? See, our function, it's an x squared plus 3x. So I'm going to write it on the side so you can see. Here we go. We're going to do it x squared. Actually, I'll use f. F of x is x squared plus 3x. Let's practice the rule again. The derivative, which is to find the gradient. Let's do the first one. We just did this one. The derivative of x squared gave us what? 2x. So when we used the rule, we said bring the 2 down, minus the power by 1. So it became 2x. Let's do the same for the next one. What's the power of x for right now, for this term? 1. So according to the rule says bring the power down, so it's 1, times what's the coefficient? 3. Very good. So the number in front of the function is 3. So 1 times 3 And then x to the power of 1 minus 1. So the rule said minus the power by 1. Can you see how I did it? So this one minus the power by 1, that's how I got 1. Brought the 2 down to the front. And the coefficient is 1, so it's 2x to the power of 1 plus 1 times 3x to the power of 1 minus 1. So I'm just sticking to the rule. So here, let's simplify. This becomes 2x plus 3x to the power of 0. But we know that x to the power of 0 is the same as writing 1. And when you write 3 times 1, that's the same thing as saying 2x plus 3. This now gives you what we call the derivative. What is the derivative? The derivative finds the gradient at one point. Which point did we want again in that question? At x equals 1. So at x equals 1, can you see, if I substituted 1 into this rule that I figured out for the gradient, it would be 2 times 1 plus 3. And you end up with 2 plus 3, which equals 2. You can do this in your head eventually. The deriving part you can find, just bring the power down minus power by 1. You can get the answer of 5 just the same way as we did with first principles. But that's quicker. Okay, and the reason why it works is because of first principles. You needed first principles to derive the rule. But that's how it works to find the gradient at a point. Yes, Raha. Very good. So that's what we're going to practice today. So what happens when you get different scenarios? Okay, so we're going to practice this so you get a feel of how would you use power rule. Now, for those who aren't really confident with power rule yet, you can actually use your CAS to do this as well. And I'm going to show you. So I'm going to go define f of x. You don't have to do define if you don't want to. I'm just doing define. Go to menu. Calculus is number 4. And the first one says derivative. That's what I was teaching you. So if you go menu 4.1, what goes on the bottom? Always x, because you're deriving in terms of x, so it's x's, so that's why it's x on the bottom. Usually here you type in the equation, so x squared plus 3x, but because I defined it, I can actually just type f of x. This should find the derivative, which what you guys did by hand just now, gave you 2x plus 3. Okay, so if you want to find the derivative of, say, this example, so this one should have been f dash of x, bring the 2 down, so 2x, 2 minus 1. This is 1, bring the 1 down, so it's 1 times 3, x to the power of 1 minus 1. You get 2x plus 3x naught, and that's how you get the answer, right? Let's try this one now. I'm going to do it on a CAS, and then we're going to do it by hand. Here we go. Second one. Menu, calculus. Derivative, number 1. So menu 4.1. X on the bottom. Inside the brackets, I'm typing the equation. The equation is 3 times x squared plus 7 times x cubed minus 4 times x plus 10. This is what the derivative should end up being. Okay, so it should be 21x squared plus 6x minus 4. Let's see if we get the same answer using the rules. So let's practice. Here we go. Let's break them all apart. First bit. This is the proper notation to say derivative, if you're curious. This is Leibniz notation. Here we go. First one. Same thing again. What's the power for the first term? The one that I highlighted. 2. Rule says bring the power down. So we got 2 at the front. Coefficient, which is clearly 3. So 2 times 3. Function is x squared, but remember you minus the power by 1. That's the rule. Okay, so the rule is bring the power down and then minus the power by 1. Let's work this one out. What does that give you? 2 times 3? 6. So this becomes 6x. Let's try the next one. Plus. Do the same thing. What's the power for the second term? What's the power? 3. Bring the power down. So bring it to the front. It's 3 times the coefficient, which is currently 7. The function is x cubed. But remember, you minus the power by 1. So it's 3 minus 1. So this should now give you 21 x squared. Let's try the fourth one. Oh, the third one. Third term minus 4x. What's the power for the third term? 1. So bring the power down to the front. And again, same thing again. It's plus, what, 1 times negative 4. Because the coefficient is negative 4. Power is x to the power of 1 minus 1. That should give you now the third term simplified as negative 4. And x to the power of 0 is just 1. So it's just negative 4. Or just to help you out, I'm just going to write the 0 in front so you can see. But Raha's question was, what happens when it is just a number? Now I ask the same question. Let's see if you can figure it out. What is the power for the last one? Because remember, it has to be a function. It has to have an x to the power of something. Who said 0? Or whoever said it, you're correct. You see that 10? That's a constant. But you can make it a coefficient by saying, well, 10 times 1 is still 10. But to get 1, you can write it as x power 0. Then you can use the rule again. You can say, pull the 0 to the front. And then you'll end up with 0 times coefficient is 10. X power of 0 minus 1. But what do you notice already? Yes. But 0 times anything is 0. This 0 at the front is always going to make it 0. So it doesn't matter. Every time you have a constant, if you don't have a variable, it will end up being 0, the gradient 0. Technically, if I showed you theoretically, there's a lot more reasoning to why that is true. But for now, I'm just going to pause there and just teaching you techniques. Okay? So, what does that mean? You have just figured out the derivative rule. It depends on where you want in the graph. If you want to find the derivative or the gradient of a line at a certain point, well, you need to know which point. That's what the x is. So here's an example. Let's say your question was y equals 3x squared plus 7x cubed minus 4x plus 10x. And I said, find the gradient. So that's that equation there. If I asked you, find the gradient or instantaneous rate of change at x equals 1. What you would have to do now is you'd have to sub 1 into the derivative to find the gradient. Now, if we sub 1 into the derivative, what would you get? 6 times 1 plus 21 times 1 squared minus 4 times 1 to the power of 0. 6 plus 21, take away 4. Is it 23?
27 minus.
Oh, yeah, you're right. That took me a while. 23. Let's prove this. I'm going to use a calculator to prove my point. That the gradient for this graph should be 23 at that particular point. Here we go. On your CAS. You already found the derivative. Okay. I'm going to prove to you the gradient is actually 1. So here we go. I'm going to go menu, 1, 1, define, f of x. Let's read it again. It was 3x squared plus, what was it again? 7x cubed. What was the other one? Minus 4 times x plus 10. Last session, I taught you how to find the gradient, or pretty much the tangent line. It was menu, calculus, tangent line. Okay, menu 4-9. Watch what happens here. Menu 4-9. Our function is this one, which I defined already. So I can just say f of x, comma. Now, where do we want to find the gradient? We want it at x equals 1. So you say x equals 1. Look at the equation they give you. See that 23? That's a linear equation. That's mx plus c. M, you figured out using the power rule, and you sub 1 in and you found 23. You just didn't know how to find out minus 7. But later on, you could learn that. That's the whole point of calculus. You can actually figure out using year 9 mathematics to find minus 7. But you can now find the gradient at one point. You see, if I actually sketch this graph so that you could see it, let's do it on Desmos so it's a bit more visual. I'm going to take this off. Here we go, same thing. F of x equals 3x squared plus 7x cubed plus 4x plus 10. This is what your graph looks like. But if I then now type at x equals 1, which I want to know where the y value of f of 1 is, it's at 24. Okay, cool. So 24, there we go. So 1, 24. And we just figured out that the gradient or the line from the CAS calculator was y equals 23x minus 7. All right, did I type the equation wrong? Oh, it's minus 4x. Whoops. Minus 4x. Can you see that this line, the blue line, is 23 minus x? And if you notice, it will cross exactly at 116 and nowhere else. Look at that. If I zoom in, look at how perfect that is. If I zoom in, you can actually see the line does not intersect until it actually gets to, oh my God, it's taking so long to get there. When it actually gets to, I have to zoom out to see where it is, at 16. You see that? If you zoom in, it only touches exactly one point. Of all the points on that curve, we figured out where. So you need to find the derivative, sub in the x coordinate to find the gradient. But what I just showed you on your CAS is that actually figures out the equation. You haven't learned how to find the equation yet. That's one of the applications to it. But you learned how to find n. Okay? I'm going to pause there because that's all you really need to know as an intro. I wanted you to learn power rule. Have a go with these two. That's it for today's lesson. You got about 35 minutes. I'm going to hand out your exams. And you can go in OneNote to look at the solutions. All right, here we go. I'm going to pause the video.